What up, fam? Welcome back to another lesson with Mr. Biza, and let's get learning. In today's lesson, we're going to be learning about the volumes of cones. The cylinder and cone have the same radius and the same height in our first example. The volume of the cylinder is 120 inches cubed. The volume of the cone is 40 inches cubed. In our second example, the cylinder has a volume of 90 inches cubed. The cone has a volume of 30 inches cubed. So when we look at these two examples, the one thing that we notice that a cone has 1/3 the volume of a cylinder with the same height and the same radius as the other. So when we're looking at the two examples, since a cylinder was 120 inches cubed, 1/3 of that would be 40 inches cubed, which is the volume of a cone. In the second example, the cylinder was 90 inches cubed, so the volume of our cone was 1/3 of that, which is 30 inches cubed. So let's go ahead and write down some notes to match this information that we're learning about the volume of cones. The volume of a cone will always be 1/3 the volume of a cylinder that has the same height and radius. The formula for the volume of a cone is volume equals big B, the area of our base, times the height, times 1/3, because the volume of a cone is always going to be 1/3 the volume of a cylinder. But when I'm working on my problems and I'm doing this math, multiplying by 1/3 can sometimes be difficult. So another way that I could write the formula is the volume equals the area of the base times height divided by 3. Now, since the base of a cone is a circle, the area of the base uses the formula A equals pi r squared. The formula for the volume of a cone can now be rewritten as the volume equals 1/3 pi r squared times h. Or we can do it another way and find the volume using volume equals pi r squared times the height, and all of that divided by 3. Alright, so let's go ahead and use that information that we just learned about the volume of cones to find the volume of each one of these examples. So here's our first example of a cone. Whenever I'm finding the volume of something, I like to use a table to help me organize my thoughts. So let me go ahead and work on my table first. Alright, so when I'm looking for the volume of a cone, I'm going to use my formula. Our formula that we said we're going to use was volume equals, we had our base times our height divided by 3, but we recreated that because we know the base of our cone is a circle, so we said pi r squared times the height, all divided by 3. Now my next step after I write my formula is I go ahead and substitute. Now in this problem I'm looking for a volume, so the V is going to stay the same. Instead of pi in all of my examples, I'm using just 3 to represent pi. The radius in my problem was, if I'm looking at this going up and down, this is my height. The radius is the distance from the center of my circle all the way to the outer edge. So the radius of this cone is 5 inches. So we're going to do 5 inches squared times our height, which we just said going from the base all the way to the top of that point is 12 inches. So 12 inches. And we divide all of that by 3. And that's what we're multiplying. And my last step is to go ahead and solve. So let's go ahead and do the math. Alright, so I went ahead and worked out the problem, and I did it step by step looking at everything that I did before I went ahead and substituted. So as soon as I substituted, the first thing I wanted to work on was the exponent to the power of 2. So now I have 3 times 25 inches squared times 12 inches, all divided by 3. Now I'm multiplying from left to right. 3 times 25, that gives me 75, and I'm still in inches squared, times 12 inches divided by 3. My next step is to multiply 75 inches squared times the 12 inches. That math was a little bit difficult. Had to take a pause and do some math on the side. So 75 times 12, first starting with that 2 in the ones place, 2 times 5 is 10, 2 times 7 is 14, plus 1 more makes it 15, so I get 150 for my partial sum. Then I'm going to the tens place where there's a 1. So I put my placeholder because I'm in the tens place. 1 times 5 is 5, 1 times 7 is 7. So now I add up these two partial sums and they end up equaling 900. So that means 75 inches squared times 12 inches is 900 inches to the power of 3, because I had inches squared and now I'm having another inch that I'm multiplying. So I have 3 of those inches being multiplied, inches to the power of 3. But I'm not done yet because I still have to divide by this 3 on the bottom. So 9 divided by 3 is 3, so 900 divided by 3 is 300. So the volume for this cone was 300 inches cubed. So I'm going to go ahead and work on one more example before we go. So make sure you hit like and subscribe on this video because it really helps me out. Alright guys, so here I have my perfectly drawn cone. Couldn't be drawn any better and better to scale. So on this cone I got the base is my circle, because the base of a cone is always a circle. So this is my base, and the height going straight up from my base is going to be this 10 centimeters. So now I can see going all the way across is 22 centimeters, and going from the base all the way to the point, that is 10 centimeters. So when I'm looking for the volume of anything, the first thing I like to start off is with my table. And the formula for my cone is pi r squared times the height, all divided by 3. So now we're going to go ahead and substitute. Again, I'm looking for the volume of this whole thing, so the letter V is just going to stay V because I'm still looking for volume. We said in our problems, instead of pi, we're going to use the number 3. We're multiplying it times the radius of our shape. So in this one, I'm going all the way across this circle from edge to edge. So when I'm having the radius, I am going from the center of a circle all the way to the edge. This is going all the way from edge to edge. This is going to be my diameter. And half of my diameter is what I need to give me my radius. So half of 22 is going to be 11. So for my radius, it's going to be 11 centimeters. And we're going to square all of that. Times our height divided by 3. Let me put these in parentheses. So I'm doing 11 and my centimeters, and I'm squaring all of that. So now that I substituted all my numbers, my last step is to go ahead and solve. All right, so let's go ahead and do the math. Alright guys, so I worked out the problem. Let's go ahead and check what I did. So the first thing I did is I want to get rid of this square part, so I squared. I multiplied 11 times 11, which gives me 121 centimeters squared. So now I have 3 times 121 centimeters squared times 10 centimeters. So I forgot to mention the height of our cone right here, going from the base all the way to the point, was 10 centimeters. So that was our height in this problem. And we divide all that by 3. My next step, multiplying from left to right, 3 times 121 gives me 363 centimeters squared times 10 centimeters divided by 3. I multiply 363 times the 10, gives me 3,630 centimeters cubed divided by 3. And my final answer is 1,210 centimeters cubed to the power of 3. Remember, whenever I'm doing volume, the units that I have are always going to be to the power of 3. They're going to be a 3D shape. Alright guys, so if you like this video, make sure to hit like and subscribe down below. And until next time, bye! What up fam? Welcome back to another lesson with Mr. Bina. Wow, I said my name wrong.